Okay, we're going to talk a little bit more about the mechanism of how the water jet cutting head works. And as long as you understand that, at least you'll hopefully have a better idea and feel for what's going on when you and while you pierce, and why you're getting blowouts, and how to try to address them and what could be the cause. Okay, rough picture. Here's your cutting head, your nozzle, we've got the abrasive cutting coming in, we've got the high pressure water coming down here. The process is the water comes through, comes up against an orifice, will come out as a stream of water that will come straight out the nozzle. This of course is traveling at 2200 miles an hour. Depending on what style cutting head you have, there might be some kind of chamber, some kind of wear chamber in here, so that you actually wear away the chamber as opposed to wearing away the whole body. All the water jet cutting heads typically have a wear chamber inside them, wear insert. You've got your abrasive coming down here, and the way it gets drawn in is a process. The first thing is you turn your water on. The water will come up against the orifice, it'll be forced through the orifice, it comes out the orifice at your 2200 miles an hour and goes shooting out the nozzle. That's your pure water only. As it comes out here, by the Venturi effect, it's just a scientific thing, it creates a vacuum. So if you took the abrasive tube off and you put your finger on here, you should feel a good strong pull of the vacuum trying to suck your finger, and you take it off, there'll be a little white marks there. So you can always test the quality of your orifice and your nozzle and everything by simply just putting your finger on there. Okay? We rely on that vacuum to efficiently remove the abrasive and draw it into the stream and mix it up and take it out through the cutting head. Let's just flip to the abrasive side. The abrasive is typically dropped into this tube by gravity or some form. Gravity, of course, is the most consistent, but even water jet has different style mini hoppers, some which is just a valve that opens, and depending on the opening and the aperture that you have, more or less abrasive falls out. And it just drops into a tube. That's it. It's going to run down this tube, but it's going to be encouraged by this vacuum that is drawing it away. But the vacuum should only be able to draw and consume as much abrasive as you're dropping in. So if you put too much abrasive in here, the vacuum is not going to be able to take it all away and absorb the abrasive, sorry, the water is not going to be able to take all the abrasive away and absorb it into the stream, and as a result you'll find the abrasive starts to clog back up here. If you don't have enough abrasive coming down, then of course you're not cutting at maximum power. Your cutting power with abrasive is determined, abrasive water jet cutting is determined by having the right amount of abrasive. If you're running a 10-30 orifice nozzle combination, you typically want to be about 0.6 to 0.7 pounds per minute of abrasive. If you're running a 14-40 orifice nozzle combination, this would be a 25 horsepower pump, or 30, you could actually get away with more. A 14-40 would be a 50 horsepower pump. This of course could be two heads, each running from a 50 equivalent of 25. And here you're going to be more at about 1.2 to 1.4 pounds of abrasive. You can see almost double. But you can cut at about twice the cutting speed with a 14-40 as you can over a 10-30. So just getting back to here, presume that we've got the optimum amount of abrasive coming in. You've got your water coming down here. Just going back to where we were, it's a step-by-step process. Step 1, water pressurizes up against the orifice. Step 2, it's forced through the orifice. Step 3, it creates a vacuum. That vacuum then draws the abrasive into the stream, and then it comes out. Now, the problem we have with stone. If we were cutting steel, we wouldn't even have to have this discussion. because with steel you can hit the water. Remember, the water comes out first. You can hit the steel with water and it just sprays out and does absolutely nothing. If you take your water jet, and I suggest you take your water jet and you take some stone and different kinds of stone, and with water only you jog your head over, and at full pressure just simply turn it on straight over the stone and watch what happens. You will blow it to pieces to different degrees depending on what marble or granite. If it's a travertine, it's not going to be so bad. If it's some kind of granite, it will just shatter it to pieces. Worth doing it. Make sure you're wearing safety glasses because you're traveling at 2,200 miles an hour. But that's what's going to happen. If in the process of switching this on, it's going to go step 1, 2, 3, it's going to shoot the water out here. The water will hit the stone first, and it will just shatter the stone to pieces in a localized area. Only when the abrasive is mixed up with the stream does it actually have an abrasive eroding power, so that that mixture of water and abrasive starts to dig through here, as opposed to just destroy it and tear it to pieces with water only. So we must have abrasive plus water. We've almost got to have that mixture completely as cohesive as possible, so that we get true cutting power. The challenge being, how do you get the abrasive in here when the first thing that has to happen is the water has to come out? Now, there are different ways of talking about this. There's different ways. There's things called vacuum assist by some other people, where they'll have another tube here and they suck a vacuum, and then they draw the abrasive across first, and then when the abrasive is flowing, then they turn the water on, so the water has to go through the abrasive. That can be offered by multiple companies. That can be done. It's easy to, you can buy parts that do that for you. But generally, and let me just complicate this one little bit more, okay? Let's talk about switching off, all right? Let's say that you can get the abrasive in there and you are cutting. In other words, you pierce off the material, you allow that to happen where you're not on the stone, you've got the power, now you start to come in and you start cutting. Well, of course, you've got a cohesive, abrasive water stream, and it cuts through and it does a great job. Let's say that that's all happening, and now you switch it off. Well, one of the things that happens with the water jet cutting head is you never want your abrasive to get wet. Never. Humidity can cause problems. If you're loading a bag of abrasive into your bulk feed hopper and it's a hot day and a bead of sweat drops into that bag, it will glue the few pieces of abrasive, grains of abrasive together. They will find their way into the bulk feed hopper, they will stay together, they will come through the mini hopper, and they could get stuck. If they don't get stuck, they might get through here, and you suddenly land up, and I know it sounds impossible and I don't understand it, but you land up with 3 grains of abrasive stuck together, and as the water goes down there, it lodges them against each other. Bam! You get a blockage, and all this water, instead of coming out here, gets pumped and it shoves it straight up the abrasive line, and it just goes, depending on what you have, it'll go straight into your mini hopper. Now, we have something called a anti-backflow device that is specifically designed to address this. Okay, so from the outside it looks like this, but actually from the inside and on a cutaway, what we are doing is, this is the hose that would go to the abrasive, to the cutting head here. This is the hose that's at the cutting head, and what we have is these little flaps. So should you get a blockage here and the water is shoved back up this pipe, it's going to come straight back up here, it's going to come in and it's going to spray out here, it gets diverted, it's going to spray out here, and the intention is that the chance of water continuing to get back up into the actual mini hopper is very slim to none. If you don't have one of these, I suggest you get one. They are worth their weight in gold as far as trying to address things like this. So we never want the abrasive to get wet or moist, or even humidity can be an issue. But here comes the next challenge. When you switch your cutting head off, we go through a process. Just like when we switched it on, we go through a process. When we switch it off, we go through a process. What happens is when you switch the water off, it's almost as if there's a solid iron rod of water, and that last piece of water that's under pressure gets forced out through the cutting head. As it leaves the cutting head, it leaves a vacuum behind it. And old systems, we used to actually have air. We would pump air down here. So when you switched this off, the air that's on the solenoid got diverted and pumped down here so that we'd actually pressurize in here so that we didn't get all the air rushing back in here and damaging parts inside here. Then if you just switch this off, your rod of water comes out and the air comes back in here at, let's presume, 2,200 miles an hour. And it comes and it fills this void as quick as that. If you have abrasive all around here, that abrasive gets slammed against every part of the inside of the cutting head, and depending on the design of the orifice relative to the chamber, a lot of cutting heads don't even have this chamber. Some abrasive could get up and actually hit the bottom of your orifice, and it would chip your orifice, and it will break your orifice, and that's it, bam. You switch your head off, it's done with the abrasive in here. So what we do is we typically like to go through a process called purging the system of abrasive. The ideal way to switch the cutting head off would be go through 1, switch the abrasive off. 2, let the water run for a second, half a second, quarter of a second, whatever. That water continues running, the vacuum continues to draw all the abrasive, because this is now switched off. It draws the balance of the abrasive and it shoves it all out of the system. This is now void, there's no abrasive inside there. 3, you switch the water off, the air comes back up here, there's no abrasive to actually throw around and damage against everything, and as a result, your orifice will tend to last a lot longer. So that's a typical switching off cycle. We've gone through the switching on cycle. We have a major problem. The problem is, when you come to switch on again, there's no abrasive here. And with no abrasive here, you are going to get water coming down. And that water is going to, by itself, damage the top of your stone. So, in the next session, we'll discuss how you get around this.